content. I'm just going to try and summarize just in kind of a different way, just so that you know you're getting it both ways. Now, don't just look at this video. Make sure that you actually go through the content. And also below here, we have that portfolio, which is kind of your notebook. Make sure you do those definitions, okay? And when you do definitions, it's not just good enough to just copy and paste off the internet. Because again, your goal is to actually understand the concept. And if you truly understand the concept, you should be able to use those terms in a sentence or in a paragraph without having to refer, well, what's the definition again? What's the definition? Okay, if you truly know the definition, you should be able to use those terms in sentences, no problem. Okay, so let's take a look at kind of my summary of what we should have learned in this first content. Okay. So these are the chemistry basics, just some review of some essential chemistry. So all living things, like you, are made up of all of these little tiny atoms. All living things are. So when you look at the body of this orangutan, I mean, its forehead, its eyeballs, its fur, all of its organs inside. If you really got close enough, you'd see they'd make up all these different types of these little tiny balls, which more correctly, as being a chemist, we would call them atoms. Okay, so everything, all living things are made up of these atoms. Now, the different options for atoms are what we call elements. So what type of these balls are going to be? Are they going to be a carbon ball, or is it going to be a hydrogen ball, or a sulfur ball? Okay? So the elements, which we have here on the periodic table, are all the different options for those balls, okay, or all those for those atoms more specifically. So although there are over 100 elements, and again there's over 100 elements here, okay, only 6 are used to make a cell or a living organism. Out of all of these elements, we only need 6 to build a bacteria, to build a frog, to build a lizard, to build a human. You only need 6 elements to build them. Okay, and again, we've talked about that before in my newsfeed called chenops. These are the 6 elements. So carbon, okay, which is right here. Hydrogen, which is right here. Nitrogen, which is right here. Oxygen, which is right here. Phosphorus, which is right here. And sulfur, which is right here. Okay? So if you notice, all of these are non-metals. Okay? So to build a cell, okay, not to run a cell, but just to build a cell, we don't need any metal. We only need non-metals, and those are the 6 elements that we need to build the cell. So when these elements, these 6 elements, come together, or they bond with each other, they create macromolecules, and those are the carbs, the protein, lipids, and nucleic acids. All those ones that I talked about in the first video are made up of these elements. Okay? Now excuse me, these elements always bond using covalent bonds. There's 2 types of bonds, ionics and covalents. There's metal alloys too, but they're not really bonds. But when you build a molecule, or you build, say, a cell more specifically, you don't need any ionic bonds. It's all covalent bonds. It's all going to be flexible. And covalents, again, are 2 nonmetals bonded together. And again, all of these are nonmetals. So when they bond together, of course, they're going to be covalent because they're all nonmetals. Now, different elements have different bonding capabilities. And what I mean by bonding capabilities is how many things can attach to a carbon atom. Well, a carbon atom can have 4 things attached to it. So it could have 4 hydrogens attached. It could have, 4 chlorines attached. It could have 4 fluorines attached. So carbon has 4 things that can attach to it. Hydrogen can only attach to 1 thing. Okay? Nitrogen can attach 3 things. Oxygen can attach 2 things. Phosphorus can attach 3 things. And sulfur can attach 2 things. Okay? Now, we kind of have to know this, but it's not really memorizing it. We hopefully more understand it. And that's what the next slide is going to try and teach, kind of understanding of why. Why can carbon handle 4? Well, when we look at a carbon atom, and this is our carbon atom, our Bohr diagram, so if you remember from grade 9 or 10, or if you've taken grade 11 chemistry or 12 chemistry, I mean, you should know these Bohr diagrams. So here's our carbon atom. Now, on the very first ring, you can only have 2 electrons. Here's an oxygen atom, and you can only have 2 electrons on the first ring. And as far as you're concerned, because we're not going to get into quantum mechanics, you can only have 8 on every other ring. Okay? Now, the electrons on the outside rings are the only ones we care about. They're the only ones that can do bonding. So bonding only involves the sharing of electrons in the outer ring. These electrons right here cannot do bonding, and these electrons right here can't do bonding. So we don't really care about them too much. Okay? So these are Bohr diagrams, but what's a lot more useful is what we call Lewis diagrams. And this is a Lewis diagram. It's not as much detail, but it basically just represents the number of electrons in the outer energy level. So if we look at carbon, I've got 1, 2, 3, 4 electrons. So my Lewis dot is 1, 2, 3, 4. Okay, I look at oxygen. Okay, I don't care about these interior electrons, but oxygen's got 1, 2, 3, 4, 5, 6 in its outer ring. 1, 2, 3, 4, 5, 6. Okay, so the most you want to have is 8 Okay, so you really, on your outer ring, you want to have 8 total electrons. Okay, if you're a metal, you want to have 0, but I mean, I don't want to confuse you with that. So just kind of remember that you want to have 8 electrons in your outer shell. So if carbon's going to want to have 8 electrons, it's going to need to bond with 4 things so that I can have an extra electron here, 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 and here. Those are going to be my 4 bonds. Oxygen, we go back. Oxygen only needs to make 2 bonds because I've already got 1, 2, 3, 4, 5, 6 electrons in my outer shell. I just need to share one here and to share one here. Okay. So when we look at our things, carbon, it can make 4 bonds because it's got 4 electrons in its outer shell. Okay. I'm going to skip over hydrogen for a second, go to nitrogen. Okay, nitrogen's got 1, 2, 3, 4, 5 in its outer shell, so it can make 3 bonds, so it has a total of 8. Oxygen, it's got 6 in its outer shell, it needs 2 more bonds to make a total of 8. Now hydrogen's special, okay, because if we go back, and our first energy ring can hold 2. So hydrogen either needs to donate an electron or to grab an electron, but it only needs 1 because it needs to fill its outer shell, and hydrogen's outer shell would just have the 2 electrons. So hydrogen's bonding capability is only 1. Okay. All right. Now, if an atom, like carbon, shares more than 1 electron with another atom, like oxygen, so that's what we have down here. We've got carbon and oxygen, and they're sharing more than 1 electron. Okay. Again, carbon needs to share 4 total. So we've got each bar represents 1 sharing pair. 1, 2, 3, 4. Okay. But it's sharing 2 electrons with this oxygen, and it's sharing 2 electrons with this oxygen. And when they're sharing more than 1 electron, that creates double bonds, or if they're sharing 3 electrons, that's a triple bond. Okay? And that's pretty much everything for the content on this page. Okay? So now I'd like you to work on your portfolio and get those definitions done.